So this is stuff, again, we're back into review mode. We're going to deal a little bit here with graphing inequalities. We'll get to some actual, like, on a grid graphs, just not quite yet. So inequality, instead of equals, where everything's the same on both sides, what we're going to do here instead is compare values to be like, hey, are they equal? Is one bigger than the other? Which one? And some things like that. So, again, we've seen this before. Now, here's where I'm going to add a little something. Because it's true, when we're talking about greater than, less than, the or equal to part goes directly with the line. But this, yes, it's greater than, but I like to actually put the variable in here. And again, it can be different variables. But typically when we're graphing, you're going to have x and something. And the way you want to look at it is, x is greater than some number. X is less than. You are always doing it in reference to x. X is a little bit, in inequalities, a little bit of a diva. Sometimes it's like, no, it's about me. It's about me. So we kind of just succumb to that in this case. So when we go to start graphing these, we're going to be doing these ones, at least for now, on a number line. We will get to some stuff, like I said, with the graphing things later. And so when we graph on a number line, we still have to portray a couple bits of information, not just one. So yes, graph x is less than 3 on the number line. You're like, well, the number's lesser this way. So you're like, all right, okay, I got an arrow. Bad arrow, but it's an arrow. But there's still one more bit of information whoever's looking at this needs to know. Do I get to include 3 or do I not? So if it's just less than, I'm not including 3. We're all the way up to like 2.99999, not 3 though. So that's where we're going to get into our symbols here with the open and closed circles. If it's just greater than or less than, we're going to use the open circle. If it's or equal to, we're going to use the closed dot. So here, that one extra piece of information that we're giving through the open dot is up to 3. We're just not going to count 3 with it. One more piece here, and then one more kind of hint that may help out moving ahead. Graph x is greater than or equal to -4, okay? Greater than -4, we're heading to the right. That's where the numbers are getting bigger. Greater than or equal to, we're going to have a closed dot. But here's where I want to put out some caution. Sometimes people get what I like to say suckered into arrow following. They're like, oh, so all I got to do with these is if the arrow points left, I go left. If the arrow points right, I go right. As long as x is on the left, that's true. But what we've got to keep in mind is sometimes it's going to be written the other way. Or this one may be written like this. Now, if I follow the arrow here, that one would be going left. If I follow the arrow here, that one would be going right. And I got to be careful. Remember, x is a diva. X, it's about x. X is less than. X is greater than. Because again, the arrow's eating x, makes it bigger. The other one I like to do when I'm trying to remember the whole less than, greater than thing if I'm not sure. Okay, x is greater. It's being eaten, Hardy likes food. So it gets greater, it gets bigger as it's eating it. But if it's pointing at it, it's like, x, you are, number, you are less than I am. So there's lots of little tricks you can use to try and help out. But if x is on the left, you can arrow follow.
I will eventually use which one is the alligator eating method.
Yes, I've even seen the teeth drawn in there before. I have seen that. That's where I kind of draw the line. I'm like, I don't know if I want to put teeth on these things, but it kind of keeps life a little easier. And so when we're graphing, and we're not going to go crazy with these, I'm just going to do the first couple because I want to get more into the application part of it because that's more what we're about. X is less than or equal to 0. Less than goes left, or equal to goes closed. Or X is greater than 4. Again, the arrow's eating X makes it greater. Not much to put an arrow on there. And again, we're just greater than. So we go open circle. The reason we chatted about this is we are going to get in, as I was starting to mention, to some application stuff with this. And I wanted to make sure our graphing was good and that we didn't get, the cart ahead of the horse here. So that's kind of where we're at with some of those. But let's get the actual problems involved here. So some of this is a little bit like what we were seeing before when we were doing all those words for add and subtract and things like that. Even your inequality arrows have names, okay, or synonyms that we can use instead. And some of those are listed up here. So this is going to be a nice tool using ahead if we're not sure on something to get working. So use the word problem to write an inequality and solve it. All right, now we get to get down to some business here. Ooh. The sum of a number and 8. Now, what's sum again? Add. Sum is add, and when we see a number, that's just a variable. So the sum of x and 8, the sum of x and 8 is less than. When you're less, the arrow is pointing at you again, telling you you are less than x plus 8. Yes. Those you guys are coming up with all the good tricks. I like it. I like it. Is less than 12. And now it's just like what we'd solve with an equation. I got to get x by itself. We got a minus 8 from each side. And just like an equation, once x is on a side by itself, we're done. And then we'd be able to graph that if we were asked to. It wouldn't be a bad. Actually, let's do that in a couple of these, just kind of, again, for reference. When you're graphing a line, if you don't have a line given to you or you don't have numbers given to you, it is a-okay just to make a few lines to put your answer in the middle. And then we just make sure our numbers to the left and right make sense. 1 less than 4, 1 greater than 4. X is less than. And we've got that. So not a bad play here. Let's see. Let's do one more together. Then I'll go freeze frame on us here and let us kind of see what's going on. A pizza costs $5. I don't want to talk about pizza at 8 o'clock in the morning. Costs $5 plus 25 cents for each topping. This problem must have been written in like 1990. If you have $10, what's the maximum number of toppings you can get on the pizza? Oh, good night, man. Okay, so a pizza costs $5 plus 25 cents for each. Here comes the variable for each per those fancy words. 25 cents. Make sure it's not $25 for each topping. That would be closer to now. If you have $10, what is the maximum number of toppings you can get on the pizza? Okay. Now, maximum means I can go up to that. Right. Because I see maximum up here, but also if I think about it, I'm like, okay, I could go equal to $10, but I also could be under $10. I just can't go over. So that's where this is going to come in. Now, this is the part that's going to get fun. I can hardly wait to see how many toppings we're getting on this thing. Okay. Yeah, this is going to be ridiculous. So we got to subtract the 5 over. I'm hearing the answer already. If we divide by 0.25, Good night, man. I don't even know what to call this. Like, really? We don't need to figure this out now, but I'd like to figure out sometime. Are there even 20? Yeah, I guess there would be if you get crazy.
You could put like oranges on your pizza.
I mean, the question there would be 20 toppings on a pizza. Would you even be able to pick it up?
Yeah.
You think so?
Oh.
If it's spread out evenly, then yes.
Huh.
I mean, you could put
I should try that
You
sometime.
could put like anything on pizza. You could put.
It's true.
You could put whipped cream on it. You could.
Oh dear. Oh dear. But yeah, I might have to try some because I have had some of those like the whole like garbage can pizza stuff. I still don't think it was 20 toppings. I'll really.
The dessert pizza, it would.
Ooh. Dessert
be
pizza.
endless votes.
Ooh, that sounds good. Okay, here's what we're gonna do. I want you for a second here. I'm gonna skip 3 for a moment. Try out number 4. I'm gonna freeze frame you. Not to take attendance, but just to kind of let you look. Try it out. See what you got here. We'll do a breakdown together here in a moment. This could be a little interesting. You're gonna have to dig a little on this one. We're going to have to dig a little. Give it a shot. Take it in little pieces. So let's take a peek here. So let's see. So more than 150 students went on a field trip. So greater than 150. 10 students rode in cars. Now, they didn't say like 10 students per car. Oh my gosh, that'd be a big car. Okay, I'm getting distracted again. And the other students were separated into 5 buses. Now, what's the smallest number of students on a bus? Students on a bus is our X. So that's where the 5X is coming from. So our 10 students, or 10 random rode on cars? Oh dear, that doesn't sound safe. I would much rather they were riding in them, but okay. And then 5 buses. And that's going to be more than 150. So once I work it through, we're finding out you're going to have at least 28 students on each of the buses. Now again, it didn't say they have to have an equal number, but that would make sense to spread it out a little bit. So we could start to play that. If we had more than 150 students, we had more than 28 on each bus. But sometimes we're even going to have to use a little bit of common sense, because, I mean, you could get, like, if you got a negative number of students, I hope you'd look and go, that's not right. Like, we left students back. That's not a good thing to do. So, okay, enough of the hearty bad dad jokes here. Let's kind of jump back in here. Lamar weighs 250 pounds. All right. Lamar, got you. If he loses 10 pounds, okay, away they go. And then 2 pounds per week, there's our variable, per week after that. And he's still losing it, so we don't want to add it. We don't want to add him back on. We want to take more pounds off. How many weeks will it take him to weigh less than, left side of the equation, you are less than I am. Okay? Sometimes on these problems, it might even help a little bit to go to the end so you can figure out, okay, what's my x? Oh, how many weeks? Oh, there's the weeks. There's my x. So our one thing to be careful of in this problem, the 250 and the minus 10 are on the same side of the inequality. Don't do opposites here. Don't add 10, add 10. Don't do it. Now, at first, we might start getting a little nervous here. We're like, wait a minute. I'm trying to get this by itself. I got a minus 240. Wait, that's a negative. What the heck?
Well, About that.
But luckily, right, the x with the 2 also is negative, so this is not going to be a problem. But now here's where we see, 32.5, okay. Anybody remember from inequalities, if you divide both sides by a negative, what happens? We are going to get a positive there. What happens to the arrow? Yeah. If we got to divide both sides by a negative, we got to make sure the arrow flips. So it's going to take Lamar at least 32.5 weeks. At this rate, maybe he pumps it up a little as he gets closer to his goal. But at this rate, it's going to take him that long to get down to 175. So there's still going to be some little bits and pieces that we got to watch out for to make sure that we're good here. All right, last couple to play with. Sarah's got $325. Okay, no mention of per or with or any of those things. So $325. She's spending $10 a week. How many weeks? So she's spending, means it's out of our pocket, $10 a week on gas. What is Sarah? Sarah must be driving a motorcycle. Okay, if she wants to have at least $150 left, how many weeks can she buy gas? So again, that's where you're going to want to make sure that you're using the chart up above if you need to. We're going to end up kind of in the same situation we did on the last problem. When I minus my 325 over, again, 2 problems in a row. We got flippage. And again, it's not just because we see a negative number. It's that we have division on both sides by a negative number. So by week 18, Sarah can't go anywhere. Or she needs to find more money. Or she'll decide she doesn't need her $150 still. Okay, last one, and what do we got to do in the last one? We got to bring a fraction into play. Always got to play with a fraction somehow. Math club. We're counting the number of seniors who drive a car to school. All right. The front office tells them that no more, less than or equal to, no more than half of the seniors drive. And the maximum amount of seniors, so seniors are my X. So half of X, if they count 46 seniors driving, what's the maximum number of seniors at the school? So that time, notice, I got the arrow first, then I started to get the numbers. And again, you can figure out a way to put the numbers in first, but sometimes it's worth your while. And I don't like dividing by fractions. It's just, I'd rather just get rid of the fraction, just have it go bye-bye. No flippage this time. No negatives in play. So there's 92 or less senior, 92 or less, I'll get that out.
That's a small school.
That is a small school. I have never personally got to deal with a school that small. Everybody know everybody. I could like teach the whole senior class in one day.
I have a question. How come the sign changed for number 5? Like
The arrow flip? Mm-hmm. Because any time that we're doing an inequality and we've got to multiply or divide both sides by a negative to get the x by itself, if I don't flip the arrow, I'm actually getting the wrong half of the answer. But it's only when that negative to both sides comes in like that.
Okay, thank you.
Uh-huh. So that's basically kind of what we're doing in the play with these. So here's the task at hand. Keep these handy, especially this stuff, because it might help out. Let me flip these. So into the practice on the word problems here. We're dealing with the word problems, especially with the setup. Notice there are graphs there, so you can graph with the answers too. Do some of the graphs. I'm not going to have you go crazy with those. I'm more interested in you solving and trying to set them up as best you can. I do have, again, answers online, answers up front. But what I do want you to do today, and I rolled through those two with you yesterday. I want you to try it today. There is an error analysis problem after. So we're looking at pages 13 to 15. And we're going to kind of look and see what we think is wrong with it and then try to fix it. And I think that's going to be something we're going to talk about first thing on Monday, just to be what some ideas people came up with. But I will say this, and I think I said it yesterday, every one of these is going to be incorrect. So it's not going to be a trick question where it's like, Hardy, there's nothing wrong here. Oh, there's something wrong. There's something wrong, especially with that being perimeter. But that's as far as I'm going right now.